how do you test real-world integrations without slowing down your entire test suite? We'll see how FastMCP uses pytest markers to isolate integration tests that hit live services, plus a special pattern for testing subprocess communication. You'll learn when to run tests in process versus in separate processes, and how to skip expensive tests during local development. At pytest, mark integration. Async def test, GitHub API integration. Test GitHub API integration with real service. Token equals OS, getenv, fast GitHub token. If not token. Pytest, skip, fast GitHub token not available. Hash test against real GitHub API. Client equals GitHub client, token. Repos equals await client, list repos, JLowen. Assert, FastMCP in repo, name for repo in repos. At pytest, mark client process. Async def test, STDIO transport. Test STDIO transport with separate process. Hash this spawns a subprocess. Async with client, Python examples /simple echo, hi, as client. Result equals await client, call tool, echo, message, test. Assert result, content, text equals test. This demonstrates two key testing patterns in FastMCP. Integration testing with external services and subprocess isolation for transport validation. The first test uses the integration marker to explicitly declare its dependency on GitHub's live API, while the second employs the client process marker to indicate it spawns a separate Python process. These markers create clear boundaries between test types, enabling selective execution and resource management. The pattern works by categorizing tests based on their environmental requirements rather than their internal logic. Integration tests verify real-world interactions by hitting actual APIs, while subprocess tests validate transport layers by running servers in isolated environments. This separation allows most tests to run quickly in memory, while explicitly marking the slower, resource-intensive cases that need special handling. This approach solves the common problem of flaky or slow test suites by making dependencies explicit and controllable. You can run fast unit tests during development, then selectively include integration tests in CI. The marker system also prevents accidental execution of resource-heavy tests, making the suite more reliable and maintainable. The trade-off is slightly more complex test organization, but the payoff comes in faster feedback cycles and more stable builds. Let's break it down line by line. At pytest, mark integration. Async def test, GitHub API integration. Test GitHub API integration with real service. This marks an integration test using pytest's marker system. The at pytest, mark, integration decorator categorizes this as a slow, external dependency test, while async def enables async operations for API calls. Integration tests like this verify real-world behavior against live services. Token equals OS, getenv, fast GitHub token. This loads the GitHub API token from environment variables, keeping sensitive credentials out of source control. Environment variables are the standard way to handle secrets in CI, CD, and production environments. If not token. This is a guard clause that checks for missing environment variables. It prevents test failures when the GitHub token isn't available, allowing the test suite to skip gracefully rather than crash. This is a common pattern for handling optional integration tests. Pytest, skip, fast GitHub token not available. This skips the test if the GitHub token isn't available, prevents test failures in CI environments where secrets aren't set, while still allowing local testing when the token exists. This is pytest's conditional test execution pattern for handling missing dependencies.
Hash test against real GitHub API. Client equals GitHub client token.
Instantiates the GitHub client with the authentication token. This establishes a real connection to GitHub's API, enabling direct integration testing against the live service rather than mocks. The token ensures proper authentication and rate limit handling.
Repos equals await client, list repos, JLowen.
This makes the actual GitHub API call to fetch repositories for user JLowen. The await handles the async response, ensuring non-blocking I/O during the integration test. This verifies real-world API compatibility beyond mock testing.
Assert FastMCP in repo, name for repo and repos.
This verifies the GitHub API integration works by checking if the expected repository exists in the returned list. It's a practical assertion that confirms the real API call succeeded and returned valid data, not just a mock response. The list comprehension extracts repository names for clean comparison against the expected value.
At pytest, mark client process. Async def test STDIO transport. Test STDIO transport with separate process.
This marks the test as requiring a separate client process, isolating it from the main test runner. The client process marker signals pytest to spawn a subprocess, essential for testing STDIO transport where the client runs independently. This pattern prevents interference between test cases and accurately simulates real-world process boundaries.
Hash this spawns a subprocess. Async with client. Python examples /simple echo py as client.
This spawns a subprocess running the FastMCP example server, using a context manager for automatic lifecycle management. The pattern ensures the client connection is properly initialized and cleaned up after the test block, preventing resource leaks. This isolates the test from the main process, validating real interprocess communication.
Result equals await client, call tool, echo, message, test.
This invokes the echo tool with a test message, verifying the STDIO transport works. The dictionary parameter matches the tool's schema, ensuring proper serialization between processes. This pattern tests interprocess communication without mocking.
Assert result, content, text equals test.
This assertion verifies the echo tool's response matches the input, confirming end-to-end STDIO transport works. It validates that the subprocess correctly received, processed, and returned the test message through FastMCP's transport layer. This is the critical test for bidirectional communication reliability. FastMCP integration testing. The pytest markers and environment checks shown here create a robust boundary between unit tests and integration tests, automatically skipping resource-dependent tests when credentials are missing. Skipping tests via environment variables is preferable to failing them, as it maintains CI stability while making local development flexible. This pattern keeps your test suite reliable across different environments without sacrificing coverage.
The test that refuses to run becomes the most trusted test of all.